Hello and welcome to this brief presentation in which I'd like to introduce the Dell EMC storage portfolio. But before I do, what I'd like to do is spend a few minutes talking about the three significant storage types in use today in the industry, those being block, file and object. And after that, what I'd like to do is align some of the storage technology in the portfolio to those storage types. So let's start with block. To describe block, probably the simplest scenario is to consider an industry standard server running an operating system into which I place a hard disk drive or indeed an SSD. If I attach that hard disk drive or SSD to the motherboard of the computer using a connection protocol such as SAS, and I then format that drive and give it a drive letter, the operating system on that server can then write and read data. It does so in small chunks of data called blocks, and that's, in the simplest terms, that's why it's called block storage, because the data is written to and read from the storage in those little blocks. So I can take this scenario and I can expand it by adding more drives to my server chassis, again connecting them to the motherboard via SAS. But there will come a point in time where I've filled that chassis. Depending on the server architecture and the vendor, I could potentially add a storage expansion shelf, connect the shelf to my server via SAS, and continue to add drives over time. Now, I can expand upon this scenario by introducing additional technology such as RAID to allow me to protect my data from one or more drive failures within this solution. And of course, I can continue to expand over time until I reach a particular limit of that server technology. Now, if I were to take this idea and develop it further, I could package this solution, add redundancy features, such as, for example, a second server, which we would now refer to as storage controllers, controller 1 and controller 2. Add back-end SAS connectivity to my various shelves, and also then introduce a management overlay. And this now starts to look very much like a traditional storage array solution. I continue then over time to add such features as data services, and those might be data protection, storage efficiencies, replication and security. And of course, to make this thing useful to my environment, I need to add some connectivity as well. So even though this has evolved into a modern storage environment, a scale-up storage environment, it is still fundamentally block storage. The next obvious step is to connect some hosts in my compute environment to my storage array, and to do that I would deploy a storage area network or a SAN to my block interfaces. I then introduce one or more or potentially many compute nodes or hosts into my storage area network and give those hosts access to resources in my storage environment. So, in its simplest form again, a block storage solution, multiple hosts attached. Now, if I look at one particular host and I look at the way that the host presents its storage to a user, generally speaking, we have defined a file system. That defined system will comprise folders, subfolders, and individual files within that file system. Now, there are many scenarios in which it makes complete sense for the file system not to be hosted by an individual host on the network, but instead to be hosted by our storage solution. So I'm going to ask my storage solution to host that file system. I'm now offering file services to make that file system available to my network clients. I'm going to create a share, much like you would on a Windows server, and my clients are then able to access over IP through the share the file system hosted by my storage solution over IP. Depending on the client's operating system, we might then see certain protocols in play, SMB or indeed NFS. Our file systems in this scenario tend to scale to terabytes to hundreds of terabytes. But it may be that we want to achieve something slightly different in our environment, and particularly with our clients. We might want to grow the file system to petabyte scale. And importantly, we might decide we want that file system to be distributed globally. We might want instances of the data in three or four different continents around the world. Although it can be achieved with file systems, we might look at alternative technologies to do this a little bit more efficiently, and that's where we introduce the concept of object. So again, object is similar to file in that we may have a client, but this time, rather than the client accessing a share over an IP network, we deploy a lightweight application on the client and make it the application's responsibility to write data to our storage solution. In this case, the client is connecting to an API, typically delivered over REST, to allow the application itself to write and read data. Now, when we talk about objects, really we're just talking about files. The difference is, when the application decides to write a file to our bucket of resource, it writes the file, plus some useful metadata about the file itself, and receives back, as a result of saving the data, a globally unique identifier that describes not only the file but also the metadata associated with the objects that we've stored. Now, I said earlier on that we could distribute this solution. So let's say we build out a similar scenario in a different continent. We replicate a subset of our data to make it available in both locations. So I have some files here. All my client needs to know is that there are multiple locations in which it can retrieve the object data, and as long as it specifies the right globally unique ID, then we can give the client an opportunity to receive data at two geographies, and that scales. So that introduces the concept of object. Let's do a quick recap. We've spoken briefly about block storage. We've spoken briefly about file storage, and again we've spoken about object. Let's take a moment then to map those storage presentation types to the Dell EMC storage portfolio. Starting with block, for a modest sized environment, scaling to hundreds of terabytes, we might consider deploying SC storage, Unity. For performance workloads with scale out capability, we might deploy Extreme IO. For an enterprise class solution, we might look to VMAX. And actually for the recently announced PowerMax technology, offers massive performance over NVMe connectivity. From a file perspective, again, we have the option of selecting Unity, because Unity is a unified product, offers both block and file capability. We could introduce SC plus a suitable front-end gateway to provide that file system and share functionality. And actually at enterprise scale again, we have Isilon. Finally then, from an object perspective, typically these days we would talk about elastic cloud storage, shortened to ECS, which is the modern equivalent of Atmos and is now the data target for a lot of data that currently resides in Centera, which is now end of life. So contemplate ECS for those scenarios. We might also actually consider Isilon in some circumstances where we are able to store object data via the Swift object protocol. So that introduces the basic concepts of storage today, aligns some of the storage technologies. If you'd like to know more about these technologies, please do reach out to your Tech Data representative. We'll be very happy to put you in touch with the storage team at Tech Data in the UK. Hopefully that's been of some use. Thank you very much for your time.